to the Tyagaraja College, Pollachi. I'm sure all of you have enjoyed the previous sessions, and I'm pretty sure that the topic were informative. We all learned a lot on the state of art technologies and had great takeaways from the experts, which would help us to delve deeply into the subjects and enhance the knowledge level of our students. I'm super excited to introduce Dr. Videsh, the resource person for today's topic, Industry 4.0 and Big Data Analytics, Challenges and Opportunities. A hearty welcome to you, sir. I'm enthralled with the academic background and the industry experience of Dr. Videsh. He has done his BE in Automobile Engineering from Shanmugam Engineering College, ME and PhD in Mechanical Engineering from Anna University. His area of research are sustainable manufacturing, Industry 4.0, reverse logistics, suggestible product design, and sustainable healthcare supply chain management. Dr. Videsh is having a strong industry experience. He worked at Nandi Taito Motor World Private Limited, Alturea International, and Shohali Bhagwan Automobiles LLC in various positions such as Service Engineer, Senior Executive, and Assistant Operations Manager. Currently, Dr. Videsh is a Global Head, Product Development, Ibacostic, Coimbatore. Once again, welcome Dr. Videsh, and I request you, sir, to enlighten us on the topic Industry 4.0 and Big Data Analysis, Challenges and Opportunities. Now the stage is yours, sir.
Recording stopped.
Very good morning, Dr. Padmapriya and the team. Thanks for the introduction. Am I audible?
Yes, sir.
Fine. Thank you. First of all, a very good day for all the participants and then research scholars and professors. It's a privilege for me to be here and then give a keynote about Industry 4.1 Big Data Analytics, which is a very useful topic for present day scenario. And then I'm highly delighted to take the stage for next 3 hours. And then I would like to coordinate with all the people. And then at present I'm living in Oman. I'm living in the capital city of Oman called Muscat. So my internet may go a little bit slow due to the bandwidth variations. So once if I start the session, I'll just try to go ahead with that. I may switch off my video to get more clarity about it. Okay. So all right then. So let's go with this session. Okay, fine then. The today's topic, what we are planning to discuss is Industry 4.0, Internet of Things and Big Data Analytics.
Recording in progress.
So what are the research challenges and then opportunities, and then how we are going to make ourselves comfortable to reach them. Okay. So these are the overview of today's program. Start with the introduction, then introduction to Industry 4.0, then introduction to IoT, introduction to big data analytics, from data mining to data, big data, and then what are the challenges, opportunities, discussion and conclusion. I'm going to discuss few more case studies also, and real-time applications, and then finally simulation-based case study for IoT implementation, and then conclusion. So when start with that, Industry 4.0, we all are like aware of these words, like what Industry 4.0, and then like from where it has been originated. To give an idea about nutshell, so many of the people are from faculty of department from computer science and then computer application areas. So when we heard this word Industry 4.0, it is nothing new to the world. Maybe the word, the tagline has been given from Germany, but different countries are using different terminologies. For instance, here it shows like how the Industry 4.0, the revolution has been.
Sir, excuse me, sir. Sir, excuse me.
Please.
You can put the slideshow, and we are unable to see your slide movement.
1 minute. Can you able to see that now?
No, sir.
One. Is it visible?
Yeah, it is visible. You put it into the slideshow.
Okay.
No.
It is in a slideshow motion. What that shows.
Otherwise, you press F5 key, sir.
Yeah, no, I made it. I made it a slideshow.
But it is not showing in slideshow. You click slide 2, sir.
Yeah.
Okay, right. Okay.
It's coming, right?
Yes. Go ahead, sir. Go ahead.
Okay, fine. Thank you. So that would like in the entire world, different countries are using these different terminologies. To start with that, like this tagline has been given from Germany, Industry 4.0. There's like in Belgium they used to call it Great Difference. France it is smart industry. Like in US, like manufacturing renaissance. So like even in India, we have started initiative called Make in India. So these are the revolution how the industry has been moved from the previous era to the present era. To show with that, these industrial concept has been started in the end of 18th century, where we all know that one it started with the steam engine and then like other water production systems. From there, slowly it moved to 20th century. It's nothing but the line production system. We have to say that when it started with Henry Ford or 24, from Ford they have started manufacturing few vehicles. From there, slowly, beginning of the 17th century, the Industrial Revolution, which is nothing but with the help of with the help of information technology and robotics, it has been started. Now we are in the era like Industry 4.0, which is completely based on cyber physical system. The machine-to-machine coordination it's going to happen in this era. Almost it started happening, but places like in India, if we talk, to be honest, still we are in the Industry 3 revolution. Why? Because like we do have enough manpower to cope up with that. Whereas if you travel to country like Sweden and Japan, they do have minimum manpower utilization. So where they are completely replacing that with the help of these IoT devices and artificial intelligence devices. So here it shows like what are the like first, second, third, and then fourth revolutions happen. Starting from first like from mechanization, from second it is a mass production line for the production. In Industry 3.0 it is computer automation. That is where happening right now. The fourth is like completely cyber physical system. The difference between third and fourth is whereas in Industry 3.0 people used to give command to the computers or machines. The machines will be performing the operations, and then it will be in idle when and where like the command required. Whereas in Industry 4.4, we no need to give any command at all. Once if you inbuilt your programming, I mean, you have to communicate via your programming language so that the machine itself will communicate with other machines that will perform the activities. So, in nutshell, if you talk, the Industry 4.4 is majorly consists of three major elements. It's nothing but it is agile. It's nothing but the response is very quick and swift, and then it is highly efficient, and then it is going to be an innovative one. So this is the reason majority of the companies are focusing majorly on Industry 4.0 to make their process agile, efficient, and then innovative. So whatever process we are doing, it must be efficient one. Without efficiency, if you're doing it, because at the end of the day, the company, whatever the company or organization, they have to see the fruitfulness from the product which is going out. So in order to do that one, they have to be highly innovative. So this Industry 4.0 is bridging the gap between all these three, agile, innovative, and then efficiency process. So here it shows that like now in present day scenario, the value chain transformation is happening throughout the network and all the objects. So how this digital transformation is happening with the help of robotics, big data, artificial intelligence, sensors, software as a service, SaaS, algorithms, and then deep learning algorithms, data analytics, and then value chain. The Industry 4.0 consists of all this stuff within this. To give a brief note about it, back in 2006, these products were not existing. For instance, like the iPhone, iPad, Kindle, the 4G network, Airbnb, Uber, like Snapchat, WhatsApp, all those things were not existing. Now, when if we consider how much time it takes to reach 100 million customers, I mean, starting from the evolution of desktop, it took 75 years for telephone to reach 100 million customers. Similarly, if you consider now, Instagram, it took, I mean, less than 2 years to reach 100 million customers. Why? Because like these cyber physical systems can be accessed from anywhere and then anything and anyone can be used it with the help of cloud computing technology. So how the today's factory setups are available? To give a note about it, like rigidly sequenced car manufacturing, not only for car manufacturing, any product if you take it, whether you take it for any IT system product or like a computer or healthcare supply chain, everything has been a streamlined one. It is a well and good that like all the production is happening in a sequence manner. But how the tomorrow's industry is going to be? It is going to be decoupled, fully flexible and highly integrated manufacturing system. For instance, if a work starts from workstation A, it has to go to the workstation C and the workstation O. Even these machines can give more input than human being. Even if you're sitting idle, it will be passing information to utilize the resources. So in Industry 4.0, there are major 6 design principles. We as a researcher and then as a faculty members, we have to be concentrated more on this to cope up with the industry standards. So there are major 6 design principles. It starts with interoperability, which is nothing but workpiece or any assembly station of the product, human and smart factories to connect and communicate with each other with the help of Internet of Things and then connected Internet services. Then the visualization. The visualization is nothing but a virtual copy of smart factory, which is like created by linking sensor, which is observing data and monitoring the physical process with the visual plans, which means a factory can be accessed from anywhere and then anytime. Then decentralization. The ability of cyber physical system within smart factories to make decision on their own. Majority of the organization, what is operating right now, it's completely a centralized one, where the authoritative command has to be come from the centralized location. But whereas in cyber physical systems, we no need to wait for the centralized command. So directly we can get details from the decentralized operations. Then the real-time capability. This capability to collect and analyze the data and to provide insights immediately. For instance, like when we need the data, now the entire world is completely find up with data. So wherever you, whatever we do, we will be having data. These cyber physical systems will be collecting the real-time data and it will be provided without any interruptions. And then the fifth one is service orientation. It's offering service. It's offering service to the cyber physical systems, human and smart factories with the help of internet services. Then modularity. It's nothing but flexible adaptation of smart factories and changing requirements of individual models. This is what we need. So any technology when it comes, it has to go through for the major four phases, starting from the persuasion, knowledge, and then go or no go situation, which is nothing but adaptation or implementation. Finally, it has to go with the feedback loop and then implementation. So what are the building blocks of Industry 4.0? When we consider that, so these are the main pillars, I can say. It's nothing but it starts from autonomous robots and simulation studies, then horizontal and vertical system integrations, then industrial Internet of Things, cyber security system, additive manufacturing, augmented reality or virtual reality, then big data analytics. So these are the major building blocks which is completely holding the Industry 4.0. This Industry 4.0 concept consists of all those things, all those elements within it. So how it is going to impact and aspects of value chain? Previously, it was only for like supply chain or service chain, but now in industry we have started giving terms as a value chain. Why we are given a term as value chain? Because this system considered both process as well as the technology. In layman English, we can call it as like technological transformation. Starting from the digital manufacturing or operations, it will be compliant with the tools and pictures or machineries or factory setups. So all these things has to be worked together to give a value chain. So these are the Industry 4.4 requirements for comprehensive digitalization of horizontal and vertical chains. Suppose if we consider the horizontal chains for like supply, company and network, it is completely a process oriented. Whereas the vertical value chain is going to be a sales, a product development, planning, IT services, and then finance and tax. So how these two things are going to be work together, and then we will be giving a product output. That is what we call it as a value chain analysis. Like some of the improvements may result from the digitalization of process and value chains. For example, like focusing on core areas in individual value chain, then reduction of redundancies in the process, minimizing the quality losses, making process more flexible and coherent. So these were the systems like Industry 4.1 needed, and then majorly focusing by the present industries. So how it is going to impact the Industry 4.0? How it is going to impact? It is going to impact on the economy, business perspective, national and global standards, society, and then individual. So one or another, we all will be lying in any one of these criteria. So what are the top skills needed at present to encounter Industry 4.0 IoT? Back in 2015, now like I must say a very big supportive element to COVID-19, because during the pandemic, we all came to know how important this digital transformation, how it is going to helpful for our real-time scenario. So back in 2015, we were having few set of skills and then like elements which we need to be improved. But in present day, in 2020, post 2020, 2022, we all have to be focused on these kind of skills, starting from like complex problem solving, critical thinking, creativity, people management, coordination with others, and then judgment and decision making, negotiation, and then cognitive flexibility. Here I have not mentioned any tools. Like you may wonder, like why I have not mentioned any tools like Python, program, any other programming language. Those are the tools, but these are the skill set which people has to be improved by themselves. When we talk about the adaptation, before any kind of system comes into the place, first we have to think whether we have to adapt or not. before implementations, people have to think about the adoption. The adoption is nothing but like that's a go or no go. We all know that one, this technology is going to helpful in the real-time industry, but based on the business requirement, we have to think whether we are going to adapt Industry 4.0 or no. In order to adapt that, there are a few challenges like the security risks, complexity, and data overload. I'm going to explain about in detail about Industry 4.0 and then IoT adaptation challenges in the upcoming section, next session. So we have made a case study also about it. So what it shows that like only 26% of IoT initiatives are success so far, and then IT must ensure reliability, security, and standards. It is an infant field, to be honest, especially in country like India, in developing nations, like it is still in the infant stage. Like there are many input has to be given. So in nutshell, like many present industries, like completely highly many apps or many technologies completely distributed throughout there. So it is about us to choose the right one for our business requirement or like our research requirement. So when we start talk about Industry 4.0, the major technology which is playing as a building block is like Internet of Things. We all are aware of IoT. What is meant by IoT? In general, like Internet of Things is a network of physical objects, a device, a vehicle, a building, a human being with electronic or software sensor for network connectivity that enables these objects to collect and exchange data. The IoT starts with the help of RFID, which is nothing but a radio frequency identification device back in 1970s. So what these devices will do is it will be collecting data and then it will be sharing it and then it will be exchanging data. So to make the RFID successful, the RFID is bound to happen in a physical location and also it is having some surrounding limitation. Whereas with the help of internet, anything can be accessed anywhere from anyone with the help of internet. So there are various other names also has been given, like the M2M, machine to machine, Internet of Everything, world size web, and then Skynet. These are the other names that has been given. And cumulatively in common, in the entire world, we used to call it as Internet of Things. So these Internet of Things are consist of major three components. It's nothing but sensors, connectivity, people and process. These sensors will collect data from people and process, then it will be transferring data and it will be exchanging the data. So these data is going to be analyzed for our business requirements. So how the IoT works? It starts from the RFID. I have given one kind of sensor like RFID to identify and track the data of things. Then in order to collect and process the data, we are going to use the sensors. From there, like to enhance the power of network by developing the processing capabilities, we are going to use the smart tech, which is nothing but the middleware we used to call it. This middleware is going to enhance the data that is going to be transferred. And then finally, it is going to give a smaller thing, which is nothing but the nanotechnology to available and then to connect it to connected towards any system to interact. So these are the major three areas like where like IoT is focusing mainly. It starts with the technology and then process and people. The technology is nothing but robotics, big data analytics, 3D printing. Like the robotics is, I must say that one, it is not going to replace humans. It is going to helpful humans, especially on assembly lines. And then for like 3D printing, additive manufacturing. For process like constant communication, decentralized decision making, standardization, smart transportation systems. And also for people like increased efficiency, skill development, and then like only to handle disruptions, like only for monitoring and then making the collective action. So what is the current state and future state of IoT aspects so far in the present world? As mentioned by Warren Buffett, like change is the only thing which is permanent in this world, which is nothing but like this connected device is going to be replace the entire human beings in near future. Whereas you can see that one, the connected devices in world population is connected devices. It was only like when we were 6.3 billion, the device was 50 million. Now almost in 2020 we have reached around 50 billion connected devices. And then how these devices are going to be useful, and then how well we are going to monitor these devices. This is where the challenge lies. These challenges are going to be converted into an opportunity to provide a skill set for the people. Now, so how the Internet of Things connected as a network? So because these Internet of Things is starting from any business perspective you take it. Start from education institution, home, transport, energy, like any sector, oil and gas, or anywhere. So these individual networks are connected together with the help of the IoT devices. And also, this system is going to give high security analytics and then management to the entire systems. So how we are going to transfer the data into a wisdom? Again, I'm telling it is not a knowledge, it is going to be a wisdom for everyone. So long back in around 5 years or 6 years back, when we talk about data, it was a fancy word. When I'm explaining about big data, I will tell you how from data mining it has transferred to data analytics or big data. So we people used to give less importance for the data. So how these data have been transformed from information by asking a few questions like who, what, when, and where, and then how it has been transferred to knowledge by asking how questions, and then how it is going to be make for understanding perspective, like appreciation of why, and finally it is going to convert into wisdom. It's nothing but a benefit to humanity. How a raw data is going to be utilized and then give more beneficial to the humanity. So this is how this triangle shows. So why we have mentioned, because there are a number of data. Now, if you ask me, throughout the globe, it is completely ruled by data. But like how we are going to arrange these data, so what is our requirement, how these data are going to be useful for our business perspective, that has to be known with the help of this triangle. So imagine what happens when 50 billion machines connected with each other things. So only, as we mentioned, like the sky is not the limit, it is only the beginning of the IoT. Starting from now, the very small and then everyday usable IoT devices are mobile phones. With the help of mobile phones, you can connect from anywhere, anything, and at any time. And even now we started making the virtual reality also happening at present stage. So imagine when these 50 billion machines connected with each other, there are tremendous number of data is going to be exchanged. So are we ready to utilize those data for our usefulness? This is where the industry 4.1 revolution is started now. For taking it for smart hospital, we are given brilliant board. Earlier it was smart. Now we used to call it as a brilliant board, because why? This brilliance is going to automate everything, because we no need to give for any data at all. Once if you train your computer, once if you train your machine, it knows how to capture data. For the next time, it will be keep on doing that one. Until unless you are changing the program, it is not going to interrupt at all. So when you consider about the values of industry internet, it is going to be very huge segment, starting from aviation, power, healthcare, retail, and rail and oil and gas. You can see that one the estimated for over values are around 30 billion US dollars and 66 billion US dollars. These are it is more than our economy, how we are going to utilize it. So now the general ethical estimate that the potential is just 1% saving applied while using the IoT global industry sectors. So how we are going to unlock the massive potential of IoT? It is nothing but improve. It is going to improve the performances, then reduce the cost, the new revenue stream, create innovative services. So what are the applications for Internet of Things? As we know that one, the ultimate goal of IoT is to automate human life and then to exchange data to give a more sophisticated business perspective. In general, the IoT is available in all the fields, whether you take it in the management, retail, logistics, food or education, even in healthcare, like you name it and you will be having in IoT, even for smart houses, smart streets, smart cities, everywhere it is available. These are the few examples, starts from the wearable tech, what we used to call it as a Fitbit nowadays, and then like monitoring the systems from the healthcare system and smart appliances inside the home. This is the smart classrooms. This is like one of the case studies we have directly went and implemented in US. So this school, we have taken the school for as a pilot study. So we went, we have changed the entire SOP of the school, like the systematic operating procedure has been completely changed. Even we made a standard operating procedure, like how these classes are going to be transformed. Now we are in a pilot study to make the same system in engineering college in Tamil Nadu. It is under pipeline, like for student monitoring, and then like how effectively we can arrange these systems. So these are like with the help of IoT systems. And then like efficient smart city, which is nothing but a garbage collection truck, how well these data are going to be transferred, and then how we are going to make our city a better living place. And then like IoT applications in the shopping complex, you all would have heard about Amazon Pick and Go, which is the store is available in Seattle, USA, where like directly you can go, you can shop, you don't need to do any other steps. Automatically the amount will be reduced, deducted from your app. Then like how many steps you have walked today, like Google Fit, and then like the Fitbit Flex, like it shows, like what is your, it is completely monitoring. It is monitoring and then giving data to the systems where these data can be tracked for future healthcare perspective. Also, like I want to know that, like, can Internet of Things help us to know more about ourselves? Like where are we going, and then like it's completely human tracking, like tracking and tracing. Like how long you have been spoken to friends, how long it takes to get to work. Even smartphones like iPhone and another Android phones, it is having all these things like what is your battery percentage, how much optimized your system has worked. All those things it shows. Like recently they came up with the thought control computing. Like with the help of your thought control, they started moving a vehicle. Like recently used the EEG system to develop a toy car that can be driven towards your thought. Suppose if I am thinking the car has to be moved forward, and then they will be having a thought control computing systems that is going to be controlled. I mean, you don't need to give any other programming to the machines. Directly from human brain, the neural network is going to operate. Similarly, like how we are working in the artificial neural network system, ANN. So now, when it comes for like Industry 4.0, the few benefits are like the dynamic control of industry in daily life, then improve the resource utilization ratio, then integrating a human, society, and physical system, flexible configurations, access technology integration, and the universal internet. Okay. So these are the applications and overall popularity and then scores which has been given by Twitter, LinkedIn, and then like other network sites. So what it shows that like now people have started giving more importance for the smart homes, and then like the wearable technology, smart cities, smart grid. Even here the bottleneck areas are like smart supply chain, farming, and connected health. These are the highly debatable research areas. People has to be concentrate more on it. We as a researchers and faculty members, we have to give more empathic. I mean to say like. Focus on towards these areas so that like we can fetch more details, and then we can make our place worth living place. So now the main gateway of IoT shows that it starts from smart city, smart hospital, smart highway, and then like smart factory. Everything will be connected from a cloud services and platform. then like the intelligent digital signage is going to be helpful to make this platform, computer platform, to work under one roof. So there are a few challenges also in order to make that one. Like as I mentioned, like at present, IoT is faced with many challenges like scalability, security, technical requirements, technological standardization, and then software complexity. We as a technological persons, how well we are going to utilize these systems. Now, there are few criticism and controversies of IoT is also available. Like many of the scholars and like social observers and even pessimists have doubts about the promises of ubiquitous computing revolution. Like in the area of like how the privacy is going to be maintained, what are the security things, what are the autonomy and control, and then what are the social controls, political manipulations, design, environment impact, influence of human and moral decision making. Now we don't want to see it as a criticism and controversy. Rather than seeing it as a threat, we people has to see it as an opportunity. Where like these are the problematic area, we have to make sure that we have a skill to overcome these threat into a highly business perspective model. So what are the attacking they are giving on IoT? The major is like we all know that one, cyber attacks, because we know that one it is very default, weak and then hardcore credential, where like people can be accessed from anywhere and at any time. But now people have made many firewall systems where it will be protecting all your data. But still, again, I am mentioning this, these systems are in infant stage, where like people like us has to be give more concentration about it, so that like we will be aware of it. So like for coding errors like buffer overflow, clear text protocol, and unnecessary open ports like physical theft and then tampering. This system has to be this system has to be concentrate more on it. And also like we are facing with few other technological challenges also in IoT. Like at present, like IoT is faced with the many challenges such as like scalability, technological standardization, discovery, software complexity, like power supply, and then do we have uninterrupted internet steps? So these are the major challenges again. To give a summary about Internet of Things, see, I'm explaining in IoT initially why, because without Industry 4.1 IoT, if we started talking about big data, it shows like some myth, like from where we are starting, why this big data, why that big data is required. To explain that only, I am just giving the insights about all this. To give more depth knowledge about IoT, that is just only tip of iceberg, like where like the real potential of IoT lies. We people has to give more confident value, and like we have to concentrate more to overcome the challenges, so that like we can see the overall benefit of it. So now getting into our major topic of today is like big data. We know that one, like what is Industry 4.0, what is IoT. At least we have some idea. I mean, basic knowledge about IoT and then Industry 4.0. Now to come into big data, as mentioned, like big data is not a magic. It is like doesn't matter how much data you have if you can't make sense of it. So this is what real challenging is. We do have data. We do have n number of data and enormous amount of data. How these data are going to be utilized properly? That is where the challenge lies in. So to start with the introduction about big data, so what I mean to say is like now it has become it is a fancy word, like everybody talks about big data, but it is not easy to have an overall picture on this. What is big data? We all know that one, the data which is having the data which is consisting a huge amount of values, or which is not able to compute anything with the help of normal computers, that we are terming it as a big data. So in early 90s, the buzzword called like data mining appeared. A majority of the people used to call it as data mining. Many years later, we have another word called big data. How it has transferred from data mining to big data? That is what like the major challenge is, or like major differences. We have to know that one, how these data mining has been transferred to big data. So in order to know that one, first we have to understand that like what are the characteristics of big data. So as mentioned, data is the new oil. Data is a crude, it is valuable, but if unrefined, it cannot really be used. That is where, we all know that one. What is the demand of the fuel? Again, as a researcher, what we found is data is going to rule the world. At least for next 20 to 30 years, is going to, because wherever we travel, whatever we do, completely consists of data. So the data is having major four characteristics. Starts from volume, variety, velocity, and then veracity. Volume is nothing but data at scale, like the terabyte to petabyte of data. Variety is nothing but structured and unstructured text or multimedia in different forms. Velocity is nothing but like data in motion, like analysis of streaming data to enable decision with fractions of a second. Then the veracity is nothing but data uncertainty, like managing the reliability and predictability of inherently imprecise data. So whenever we are collecting data, we have to have a clear idea about all these characteristics, like volume, variety, velocity, and veracity. These are the major four characteristics. Before getting into data analytics, we have to concentrate this. So what is big data analytics? I mean, why is big data analytics important? So as we all know that one, like organization can use big data analytics system and software to make data-driven decisions that can improve business-related outcomes. Exactly, we all know that one. And also the benefits may include like more effective marketing, new revenue opportunities, customer personalization, and improved operational efficiency. And also like many years later, we have another word called big data, how this, because these things were very familiar even when we were doing data mining. But how this big data is going to make a change? So in nutshell, the data, I mean, today's world in data analysts, data scientists, the predictive modelers, statisticians, and other analytic professionals, they collect, clean, analyze, and growing volume of structured data as well as other forms of data not used by conventional business intelligence analytic programs. This is what they need. Why? Because we all know that when we are going to collect the data, we are going to refine it, we are going to clean and we are going to analyze it. But how well it is going to useful for my business perspective? That is what we are going to use as a conventional business intelligence. Like here is an overview of 4 steps of the big data analysis process. Like data professionals collect data from variety of different sources, like from machines, humans, process, anything it might be. Then like how the data is prepared and processed, then how the data is cleansed to improve its quality, then the collected processed data is analyzed with the help of analytic software. Because at present we do have n number of analytic softwares, then which software you are going to use, it is a myth and depend on each individual and then your business objective, what is my target audience or what is my business objective, all those things. We will explain one by one, like how these things can be implemented by us or by a researcher or by a faculty people, how this is going to be helpful for us. So these are the key big data analytics technologies and tools. There are many different types of tools and technologies used in supporting big data analytics process. Like a few common technologies and tools used are like Hadoop, you know that one. It is a like open source framework. At present, majority of the people are using Hadoop. It is something like for storing and processing the data in the big sets. We used to call it as a data lake or data pool, where majority of the large amount of data, both structured and unstructured data, can be captured, and then make the predictive analysis, with the help of hardware and software. A large amount of complex data with the use of machine learning and then deep learning algorithms to make predictions about future and then event outcomes, starting from the deterministic model to probabilistic model, and then how this predictive analytics is going on, we're going to use it. And then for stream analytics tools, which is going to filter, aggregate, and analyze the big data. And then the NoSQL is nothing but structured query language of the database, which are non-relational data management systems that are useful when working with large sets of distributed data. And also data quality softwares, which cleanse and then enrich large data sets, data processing softwares. So these are the major key elements, like data technologies, what we are using at present days. I'll give you a small example for big data analytics. What are the use and examples? It will be majorly focusing on customer acquisition and retention. As we know that one, the consumer data can help the marketing effort of the company. For example, if you take the personal engine from Amazon, Netflix, these things will be giving better customer experiences and create customer loyalty. Why I'm putting this experience on, like in today's world, whether you, I mean, you take it as Amazon or any kind of e-commerce websites, these companies have become multi-billion-dollar companies by capturing the human being data, and then they are giving personal services. So this is why they started keep on. I mean, the customer acquisition is happening. They are retaining their own people, and then the next one is like it is going to give a very big pathway for the product development. The big data analytics can give a new product developments because it will be having knowledge about like how our people are going to what is the need of their people, what is the product viability, what are the development decisions. These kind of things can be easily fit into their business customer perspective. Then the supply chain, then one more thing, sorry to interrupt, I keep on getting few chat history. Please let me complete the session, then I will be sharing all this. Please don't mind. Okay, the third one is supply chain and supply chain channel analytics, with the help of predictive analytical models that can pre-review replacement like B2B suppliers or business to business or business to customer. And then the next one is the risk management, like big data analytics can easily identify new risk from data patterns, and then improve decision making, like how the decision making is going to be improved with the help of all these steps. Because without data, if we go and talk, it is going to be, because people wants to know that one, who are the target audience, who are their customers. In order to know that one, we should have a clear-cut decision-making process. So there are major big data analytics benefits also, many quickly analyzing large amount of data from different sources in many different formats and types. And also the decision making is going to be rapidly making better informed decisions. Also it is going to be highly cost saving, which can result from new business process, efficient and then optimization, better understanding of customer needs, behavior and sentiment, and improved, better informed risk management strategies that draw from large sample of data. And then even in order to make the big data analytics, there are a few more challenges, like accessibility of data, the first one. With the large number of data, storage and processing is going to be more complicated. These big data should be stored and maintained properly to ensure it can be used by less experienced data scientists and analysts. So you make sure that one, we can collect data from everywhere, but how well we are going to storage and utilize this data. This is the major first challenge. The next one is the data quality maintenance. When it comes for data, we have to concentrate on both things. The first one is quantity as well as the quality. Are we going to collect the entire data, or are we going to collect only target audience data? That quantity is required, and also how we are going to maintain the quality. Then predictive data security. It's nothing but the complexity of big data system presents unique security challenges, properly addressing security concerns with such complicated big data ecosystem can be complex as an undertaking. Then stream choosing the right tools. This is where majority of the people are getting paid. What are the tools we are going to use it? Even if I am collecting unstructured data and going to predictive model, it will be giving obviously error solution. So choosing the right tools, and then with the potential lack of internal analytical skills. So this is where, as I mentioned, at present in today, the major skill what we require is the decision making and analytical skills, and the high cost of hiring experienced data scientists. We know that one, the data scientists and the engineers are Those are the people like they are into new product development. Those people, hiring those people is going to be tremendous effort. Like how will because as even they are into chaotic situations, like they cannot work with different business verticals because they are expertise in one field. How well they are going to utilize those potential data into different sector, again it is also a big challenge. So here it shows like what are the life cycle phase of big data analytics. Initially it starts with the business case evaluation, like the big data analytics life cycle. It's nothing but the business case evaluation. We have to fix a objective of the work. Then it goes with the identification of data. Then data collection and filtering, data extraction, data aggregation, data analysis, then visualization of data with tools like Tableau or Power BI. There are a number of tools. And then final analysis, result output. So these are the major life cycle phase of big data analytics. So whenever we are going to do a big data analytics or any kind of data analytics, make sure that we have to follow all these channel operating procedures. So what is the status of data mining and machine learning? This is where this is what the major topic. As we know that over the years, we have all kind of effective methods for classification, clustering, and visualization. If we consider that the major thing what is going to be useful is we have good integrated tools for data mining. Example like Vega or Scikit-learn. There are a number of tools. Like however, mining useful information remains difficult for some real world, because what data we are going to mine, that matters. So then when it comes, what is big data again? So though many definitions are available, we are considering a situation that data are larger than the capacity of computer. In simple words, the big data is nothing but the data what we are going to collect, it is larger than the capacity of computer. So which means these data will take more time for the computer to process. Very simple, machines to process. So these data is called as the big data. So it is the main difference between data mining and then big data. Well, data mining can be mined from anywhere, even without worrying of their quantity or how well it is. But when it comes for big data, it is going to be larger than the capacity of a computer or any kind of machines. So in a sense, we are talking distributed data mining or machine learning. That is where the machine learning, we are going to learn the systems, like how well this data is going to be captured and utilized. Here it shows the distributed data mining system. It's nothing but starting from local data 1, local data 2, local data 3. It is nothing but collect the data from different sources. Then we have to mine the data from each source. Then we have to create a local model. All these local model has to be merged together for magic technique. Then it has to be created for a global model. For instance, I will tell you one example. Suppose if I'm collecting, my objective is I want to understand the people's perception about a new technology adoption. Let's consider. So I'm going to collect data from different country domain, like all developing countries. Let's consider big countries. It's nothing but Brazil, Russia, India, and China. So I'm going to collect local data from different countries. Then I'm going to mine the data. From there, for each country, we are going to make a different local model. We are combining together with the help of merging techniques. Then finally, we are going to show it as a global model. Because we as a researchers, we as a scientists, we have to give a global model where those models can be accessed from anywhere. This is where, I know that one majority of the people, we all were aware when we are publishing a document, because it is going to be universally accepted one to show that. Similarly, even for data mining, we have to make a local data to a global model. From small to big data. There is two major important differences. The negative side is for big data analytics, not quite ready, not even mentioned in integrated tools. From small to big data, the positive side is almost unlimited data makes us easier to mine information. So since we know that there are n number of data, it will be easy for us to mine information. Because previously, when you want, because we all know that how difficult it is to collect data. But now you don't need to worry about it because the information has been scattered everywhere. So the data mining is going to be very easy for us. There are a few other challenges also, like big data and small analysis versus big data and big analysis. So this is where we have to be concentrated. Based on your object, first we have to know that one, even though my data is big, am I going to make a small analysis, or my data is also big and then am I going to make a big analysis? This is where the major challenges, right? So if you need a single record from a huge set, it is reasonably easy. We all know that one. If you have a single record from a huge set, it will be easy. For example, like accessing your high-speed railway reservation spot. Usually you can know the term because it is a time-rate process where you can access all your things. However, if you want to analyze the whole set by accessing data several times, it can be much harder. This is where the data analytics plays a crucial role. How well we are going to accessing these data several times. And also, like most existing data mining or machine learning methods were designed without considering data access and communication of intermediate research. So that is where I have mentioned earlier, like we should have the middleware to support all those things. So the data can be captured anything, but what is my business perspective or what is my objective in the research to streamline these data? Also, they iteratively use data by assuming they are readily available, but actually it is not. Because once if you train your computer, it will be keep on iteratively using the same data, but in real time it is not the original case. Example like perform your least square regression. It's not easy in distributed environment. That is what I mean to say it. When we are doing partial least square regression, it is not easy in distributed because once it is in a static environment, it will be easy. But when it comes for distributed environment, it is going to make more complex in the system. So we are facing many challenges. Like many challenges, methods are not ready, no convenient tools, rapid changes on system side by many. So what do we do now? So how we are going to overcome these challenges? So now these challenges we are going to convert into an opportunities. Like looks like we are in the early stage of this research topic, but like what are our challenges? Like we have to learn the lessons from the past developments in one machine. So it is nothing but see, again I mean to say, the same data can be analyzed with the help of different machines and with the help of different coding, with the help of different perspective. But now for research purpose, we have to make the past developments with one machine. Let us consider a few algorithms for distributed data analytics. In order to consider the data analytics for distributed system, roughly there are two types of approaches. The first one is like parallelize existing the single machine algorithm. The next one is designing a new algorithm particularly for distributed settings. It's nothing but whatever the existing parallel algorithm is there, we are going to utilize with that one. Like your open source tools like Python programming, it is readily available. We are going to do that one. The next one is like we are going to design a new algorithm, particularly for distributed settings. Like given the complicated distributed setting, we wonder if easy to use big data analytics can be ever available. See, that is what like we human being thinks immediately. Whenever we go, we all will be focusing majorly on like if suppose a major readily available tool is available in the system, it will be easy for us to go and get into it. So let's try to think about the situation on one computer first. Suppose if I am having one computer, how it is going to utilize it? So indeed, those easy to use analytics tool on one computer were not there at the first stage. That is when we all have to be concentrated more on it. Like the easy, for example, imagine I will give you an example from here so that you will be understanding it. Like the past development on one computer, like now the problem here is like we take many things for granted in one computer. That is what we all used to do. On one computer, like have you ever worried of calculating average of some numbers? We have not worried at all because like we can use Excel, statistical software. If you're asking me to perform these calculations, like calculating the average of some numbers, I can use by any software. In one machine, like I can use with the help of my mobile phones, a calculator, or with the help of the software. But we seldom can internally like how these tools works. This is where it lacks. We are least bothered about it. We will never worry about it. Like how this system works, how this computer works. We never worry about it. But when it comes for big data, we must know how it is going to work. That is where we researchers, the faculty members, the scientists, we people have to be focused more on it. So I'm giving you one example here. Like consider the example of matrix product. Let us consider any matrix. For example, C is equal to A into B. This is a matrix. This is one easy operations where you can easily write your code, own code, with the help of C programming. Let us consider we are writing with the help of C programming. Like C is equal to A into B. You are giving both input for A and B. It will multiply, it will give the result. This is what happens. Even you can use it with Excel solver or any kind of Microsoft systems. Okay. Now, I mean, there is one more question. Tableau versus R they have asked. I am going to explain it. I'm telling. See, there are n number of programmings are available, but I am giving it why these programs has to be utilized in a BLAS manner. That is what I'm giving this. Now, assume you are going to multiply 3000 into 3000 matrices. Let us consider like I'm going to make a MATLAB single thread mode. The time is going to be like 4.09 seconds. Whereas in previously, if I'm going to consider, it may take more time, like in some minutes it may take. So now you want to know that one, how this MATLAB is much faster than ours, like whatever I'm calculating, the 3000 into 3000, if I'm writing a C program or any kind of programs, even with R, like how much it is taking. With the help of one tool I'm just considering it here, it is MATLAB, because MATLAB is well aware of all the people. I mean, especially in India, we all are aware of it, how well it is going to useful for us. So here, the fast implementation comes from deep research and development. How the system is keep on continuing it. For that, we have to go back and search this, check that the MATLAB called optimized BLA. It's nothing but basic linear algebra subroutines. That was developed early in 90s. So our implementation is slow because the data are not available for computation. So we make sure that one, now we have to go back to the 90s and then we have to check these algorithms first, like the basic linear algorithm subroutine, how these has been incorporated with the MATLAB optimized programs. So this is where the big data talks. So when we talk about big data, it is not only capturing data and analyzing. For instance, I will tell you that like the optimized BLAC uses block algorithm. So we made this example because it involves both mathematical operations, nothing but the matrix product, and computer architecture, memory hierarchy. If a person only knows both, you can break through. Example for big data analytics, we are in a similar situations. Big data analytics is not like only if I know the mathematical operations, I can succeed. No, only if you know the computer architecture, you can succeed. No. So a person should have knowledge in both mathematical operations as well as the computer architecture. This is where the biggest challenge in big data analytics. Now, we as a researcher want people to understand all those things. That is what I mean to say that one, we know how to write a program and code, but we should know how that algorithm works. That is what I had given an example of that MATLAB programming for like in the early 90s, how they have built that. So when it comes for algorithms and systems, like we want to run a mathematical algorithms. It's nothing but like classification clustering in a complicated architecture. It is nothing but the distributed systems. We are like at the time period before optimized BLAS was developed. Right now, we are in the time period where like before 90s, how they have developed that. To have technical breakthrough for big data analytics, we should know both algorithms and system as well. This is what the major thing. So when we talk about big data, again I'm telling it is an infant field. We have to develop this. So in order to do that one, a person should have both knowledge in making deep learning algorithms as well as systems architecture. So indeed, if you are an expert on both the topics, so you are the most needed person, like everybody wants you right now. So we make sure that one, so we okay, there is one comment from Murugan Cheturaman. Mr. Murugan, like I will be answering all your query a bit late. Why? Because like I have many topics to cover. Okay, this is the intro again. In next section, I will be explaining you with a case study. So during that time, we will discuss. We will have a discussion section after that. So we can, why? Because like it will be difficult for me to explain all those system in one shot. That's why. Please don't mind, people. So let me, go through. Then we'll have discussion about it. Okay. So now, how these systems are going to be useful is, we as a person, we should be very good in writing algorithms. Again, I'm telling you, it is not about writing codes. Keep that in your mind. A code is different, algorithm is different. The algorithm is completely going, first you should understand what is your objective, what is your business perspective. Based on that, you have to write your algorithms. Then you can write code with the help of different kind of tools. Because in MATLAB, you're using different syntax. Even for Python, you may use different syntax. That is different again. And also, you must understand the computer architecture. Which system I'm going to use, or which tool I'm going to use. Based on that, you have to make an architecture. So again, as we mentioned, how to get started. So in order to start GitHub, in our opinion, we should start from the applications. First, we should know that one. So what are the applications? The application is nothing but programming in the framework, and algorithm. Algorithm is nothing but we make with the general tools. So if you want to start from any big data analytics, you have to start with the application. What is the application area? For example, I will tell you, if Netflix is going to make a big data analytics, it is going to, because there are a number of data available, they can collect all the data, but it is not useful for them. They have to think that one, even for example, their first application area is to, the customer retention. Let us consider the customer retention. In order to retain the customer, so what are the key bottleneck areas they have to think? And then in order to collect the data of it, they have to go with the programming framework. Then once they collect the data, they are going with the algorithm to analyze it. So that is where we talked about it. Then now almost every big data application requires special data algorithm, but we believe general tools will be possible. Indeed, if you are an expert on both topics, again, as I mentioned, everybody wants you now. But we have also gone with the same systematic approach, but we failed in many areas. Again, I'm telling you, it is a trial and error. We thought a similar algorithm would be best fit for same model, but exactly it is not. For each thing, we have to develop an algorithm. Then these topics, the big data analytics having a major two risks. The first one is it is unclear how successful we can be, because nobody knows. Again, it is an infant field, it is in a nascent stage where people have to give more concentrated, more input towards this field. We faced two major problems, starting with two limits like technology limit and then applicability limit. The technology limit is nothing but it is possible that we cannot get satisfactory result because of the distributed configuration. This is where I said, see, if it is working with the static environment, we know that one, this is where we can do it. And also in big data, you cannot go with the probabilistic model because it should be a deterministic model. You may go with the probabilistic model and then you may forecast, but again, if you ask me, the result is scientifically 100% true. I cannot say it is a truth. So the highly challenging thing is because of the distributed configuration. And also, to recall the parallel programming or HPC, high performance computing wasn't very successful in the early 90s. But now we are lucky that we have two different at this time, we are using the commodity machines, where the commodity machines are highly helpful and data becomes the focus, because we are not focusing on anything else. We are completely focusing on the data and then we are working on it. Every area has its limitations. The degree of success varies. That is what we know. One should not say that the big data is too early to conclude again. We never know until we try. Why I'm saying it is because my requirement and my objective, first I have to fix what is my requirement and objective. Based on that only, I have to check that whether I'm going to apply big data or not. Throughout the world, if we consider, we all know that we are generating huge number of data, but a very sad thing is only few people are utilizing it in a proper way. The next one is applicability limit. Again, as I mentioned, what is the percentage of application that need big data analytics? Because it is still a chaotic procedure. Nobody knows what is the percentage. Since it is not clear, indeed some things the percentage is very small. So they think big data is a hype. This is what the major problem is. Why? Because like majority of the people, what they think is only few companies are utilizing it. For example, few universities and companies can access data centers environment. Therefore, they think big ones like Google is doing big data analytics, or like Microsoft is using that one. Actually, not. They are also doing, but we people think that only they are utilizing it. In fact, situation is not like that. There is a very good quote from Dan Haley. Like big data is like a teenage desire. Like everybody talks about it, and nobody really knows how to do it. Then everybody thinks everyone else is doing it, so everyone claims they are doing it. So we are in this situation that like we all are talking about big data, but nobody really knows how to do that one, how to do that analysis. And then everybody else thinks that everyone else is doing it. I may think you are doing it in the big data analytics. You may think I am doing it, but so everyone claims that we all are doing the big data analytics. But actually, in fact, if you ask, we are not prepared enough to do that one. Why? Because for what we are doing so far, we are just collecting data, gathering data, and doing it. Until unless if you are knowing for your so-called your business interventions, it will be difficult for us. So in order to do that one, there are few skills and processes needed to be successful big data science or data analytics. Like a person must be expert in math and research, expert in visualization, expert in industry domain vertical, expert in decision making management, expert in data collection, expert in analysis tool developing. Whereas in olden days, if a person is very good in programming, he can possess that. When it comes for the fourth industrial revolution, when it comes for big data, make sure that one we all will be having all those things, because the person should be highly process oriented person, so that he knows that one what are the he must be aware of it, what are the tools we are going to use it, and then what are the techniques we are going to use it, and then how well we are going to develop the algorithms. So fine then, we will give a small break. Why? Because like I think because going to be 10:45, 11, I guess. We will join around 11 p.m. We will be joined around 11 p.m. And then from there, like I will be explaining the real-time case study, so that like we will be understanding it, how those case studies are going to be helpful, and then like how to collect the data. And then how like what were the discrepancies we have faced, and then how we have overcome, and then how those documents have been published. I will explain you that with the help of structured data, because I'm not going to, because again I'm telling it is just an introduction session, because even I am also a learner. I am also learning it. Even though we have implemented many projects, but still I myself consider as a learner. Why? Because like it is going to be an eye opener for everyone. So when the company approached us to take about it, I thought like I told him clearly that I'm going to explain it in a very expressive manner, so that like because majority of the people are faculties, and then research scholars, and then even those who are having a zeal to do research in big data. What I'm suggesting is, you don't need to worry about it. We all know that one. We all are good at one point. Now, in next session, we will join around 11 p.m. I will explain you the case study, and then I will explain you how to make a deep learning algorithm with the help of all these big data analytics. Okay. So, fine, guys. So let's join around 11 a.m. Okay. And also one more thing, I will try to answer all your queries one by one. Even if not today, I will just make a note of it. I will share my email ID also. So whatever doubts you have, you can share with me. I will respond one by one. Okay. Because like, the time what they have been given for me is just 3 hours. Within 3 hours, it will be difficult for me, because like I used to take the session for more than 6 months or 1 year. To the people, like even for development, it's like I used to take a, what do you call, session in even for universities in Germany, the US. It is a structured program, but now I will give you insights like how to do with that. Okay, fine then. So let's join by 11 a.m. Okay. Is that okay, Mr. Admin? Sorry, like I didn't ask the names. Dr. Padma Priya. Shall we join by 11? Okay.
Excuse me, sir. Let me check with
Yeah.
my director and I will let you know, sir.
Please, 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 please. Okay.
Sir, good morning, sir. Sir, இப்போ அவர் வந்து செஷன் வந்து 11 o'clock ஜாயின் பண்ணிக்கலாமா சார் பிரேக் விடுறோங்கிறாங்க. சார் இப்போ பிரேக் விட்டுட்டு 11 o'clock எகெயின் ஜாயின் பண்றீங்கிறாரு சார். அதான் உங்ககிட்ட கன்ஃபார்ம் பண்ணிட்டு. Excuse me, Mr. Videsha.
Yes, ma'am, please.
Yeah, sir, we can join by 11 a.m.
Okay, fine, fine. We'll just take a small
Thanks.
break. The next section is going to be, I'm explaining the case study.
Okay, sir.
Okay, I will explain to them. Thank
Okay,
you.
sir. Thank you.
Thank you.
Recording stopped.
Ma'am, shall we start?
Yes, sir, you can proceed.
Okay, fine. I think the participants are available now.
Yes, sir, they are available.
Fine. My slides are visible, right? Okay, fine. Okay, fine. So we talked about big data.
Recording in
Now,
progress.
we made a case study on one of the prominent technology called like Internet of Things, and then how these IoT technology adoption in healthcare supply chain management using big data analytics and deep learning algorithms. So this is where we have started a case study. So majorly in this case study, because we know that the IoT is one of the major technology in Industry 4.0 revolution, and how these technologies is going to be adapting healthcare supply chain. The reason why we have chosen healthcare supply chain is this is one of the most complex supply chains, not like other supply chain areas. The healthcare supply chain is consists of there are what do you call many stakeholders. So we have chosen this. So before getting into it, let's see that one, like what are the different types of IoT devices in health monitoring systems, like remote patient monitoring system, sensor connected inhaler, and RFID technology for traceability, and wireless enabled wearable technologies. So these are the existing technologies are available. But again, I'm telling it, this we have made it only for the case study has been made only for developing nations perspective. We have not taken any consideration for developed nations because their entire protocol is different from us. So these are the few devices. So when it comes for we have been made like what is the need for the study? As we know that one the digital technologies are constantly evolving day to day and finding new application in healthcare domain like even while the industry is struggling with adoption and digital transformation. Again, with the dominance of internet and mobile technologies, healthcare providers can also operate on an internet thing environment, whereby any healthcare persons can be access data from anywhere and anytime. So, however, again, the studies on the adoption and implementation of IoT in healthcare remains largely unknown, especially in countries like India. So that is where this shows us the bottleneck. To overcome this, we have identified IoT adoption barriers. The detailed analysis of the barriers in the healthcare supply chain is essential. So this made us to think. We all know IoT. Now, as a researcher, we all know what is meant by IoT in the Industry 4.0. Even we know that once this is going to give a very potential benefit, but nobody knows how effectively it is going to work in the particular system. In order to know that one, because straight away we cannot go for implementation. Why? Because it is highly cost-effective process, and also straight away if you are going for implementation, it takes a huge amount of people as well as huge amount of money to invest on it. So in order to overcome that, first we have gone for the adoption study. So that is what major need of the study. So from the study, we have identified few research gaps. Those research gaps are shaped as what are the potential barriers to IoT adoption in Internet of Things in healthcare supply chain, and the interrelationship between the different dimensions of IoT adoption barriers in healthcare supply chain. And there is a comprehensive framework. So we all have to keep in one mind that whenever you're going for any kind of adoption or implementation studies, we have to go with the framework or model to found that literature addressed in the dynamic nature, because this data analytics will be made only for the structured and then structured environment, not for the dynamic environment. So we have taken additional step to analyze the dynamic nature. And then what are the driving and dependence power of the barriers, and what are the weightage criteria of each barriers. So these are the research gaps has been identified with the help of the need of the study. This is what the first stage is. Whenever I said when we people are doing any kind of analysis, let us consider for any data analytics methods, first we should know why that study is needed. First, we all should know that one, why the particular study has been needed. So once you can know that one, then you have to make your research gap or objective. So from these research gaps, we have made a major 4 objectives for our study. It's nothing but to identify the various IoT adoption barriers. So this is what we are going to collect the data. So how these data are going to be used in order to identify various IoT adoption barriers, then to develop a interpretive structural framework. Why? Because here we are going to make a structural framework modeling and compute driving and dependence power of the barriers. The reason why we are going with the model is that particular objective needs a dynamic framework where it should be accepted by everyone. So in order to fulfill that, we are going with the modeling, then to find out the degree of influence between the barriers and prioritize based on the cause and effect. Which barriers are affecting more. This is what our, again, as I mentioned, when we started about the data analytics, one must know what is our need. Based on that need, you have to frame a research questions. From there, you have to make an objective. Then, which objective, which tool we are going to use. Very simple. Then, rank the IoT adoption barriers based on the weightage criteria and provide the insights to the decision makers and policy makers. Okay. So these are the objectives that have been framed. This is the research methodology we have used. It started from the literature review. Again, problem identification, barrier identification with the help of literatures and then as well as the expert opinion. Then interrelationship between barriers. For that, we have used ISM model. Then behavior classification. For that, we have implemented fuzzy Micmac algorithm. This algorithm has been modified. All those algorithms has been modified. We have taken the template of it, then we have modified the algorithm. Then determination of cause and effect relationship using fuzzy DMATL approach. Then final ranking of the barrier using fuzzy AHP. Then resultant discussion and final results. So this is how your systematic approach should go. When you are doing some big data analytics or any kind of data analysis, you have to go with all those processes. This is a systematic approach where the wrapper can be changed anytime. Even if you are doing it for your any kind of IT systematic approaches, if you want to collect data from a particular machine and then you are doing it, similarly you can follow. But make sure that your the selection of your tools as well as your algorithm should be matches with your objective. So in order to go with that one, we have identified major number of barriers, like what are the barriers which is affecting as an obstacle to get into this technology. We have gone through major journals and we have gone through many people. Finally, we have ended up with like around 27 barriers. In that, we have shortlisted around 14 barriers. These barriers, like namely a complex architecture and then like your difficulty in big data management, lack of internet coverage in the IT infrastructure, like standardization, data heterogeneity, all these things were the major barriers. These things have been finalized with the help of the experts. Again, this is what after collecting data, we have segregated. We have brainstormed with those people, and then we have asked them to rank this, because we should know that one which barrier is affecting more. In order to do that one, we have circulated the data sheets to everyone. We asked people to make their inputs. They have made an input and then gave to us. So those data has been keep on getting comments in comment section, whatever is there, because it is interrupting the flow. That is what I will share you the slide also, so that you can go through. Even you can use for your research topics also, because this study already it has been published. So I have nothing mind sharing with it. Okay, please, I will share the entire slide to you. Please. Okay, so these were the major 14 data has been segregated and then collected. So after collecting this data, now the first algorithm what we have used is interpretive structural modeling. This algorithm or this systematic approach has been proposed by Dr. Warfield. This explores the dynamic effect of various elements to evaluate complex systems in a form of diagraphic, which shows the relationship between those. Then this is the technique is interpretive in such a way the decision group of experts determines whether and how the variables related to each other or the barriers related to each other. Then it is structural in the sense of extracting an overall structure from the complex set of variables based on their relationship. Then it is a modeling technique used to illustrate a specific relationship and structure of diagram model, which will show it will give a clear-cut model to it. Okay. So this is the ISM algorithm which we developed with the help of the previous algorithm. In order to say that one, initially the list of barriers like related to IoT adoption has been found out with the help of experts as well as the literatures. Then like establish contextual relationship between the barriers, development of self-structured interaction matrix, then development of initial reachability matrix, development of final reachability matrix. We have to check any kind of like conceptual inconsistency. If there is no conceptual inconsistency, you can go with the level partition and formation of model. In case if you find any inconsistency, again you have to go with the expert opinion, then you have to change it. See, this is the algorithm which we have developed only to make that model with the help of the previous algorithm. Previously, these algorithms, there are plenty of algorithms available, but we made few changes based on our requirement and based on our objective. So initially what we thought of collecting data from everyone in the sense, even from laymen. Then finally we came to know that one, if I'm collecting, because the data is readily available from everyone. If I'm collecting data from everyone, what will happen? Unnecessarily the data amount is going to be increased and the complexity is going to be more. So in order to do that one, again, we have done a research on that one. According to Dr. Murray and Hammonds, what they have suggested is any kind of data which you are collecting, with 10 people to 15 people is ideal enough to deliberately explain about the model. That is sufficient for us. So it doesn't matter like you have to collect 1,000 number of people's data and analyze. No, you have to collect minimum of 10 to 20 people's data, but those data has to be analyzed in multiple iterations. That is where the complexity increases. Imagine if I'm collecting data from 100 people, I have to make a pair-based comparison. Again, 100 into 100, it is going to increase. Even the supercomputer is going to make more complex decision system in the door. So in order to simplify it, we have chosen a particular experts. Those experts were highly reliable and working in the areas of product development and IT policies, IT and healthcare product management system. So we have made a brainstorm with them, and then those data have been collected. After collecting the data, we made a pair-based comparison. Again, I'm telling you one thing, like these computer systems, they can very well understand only by binary values or with useful syntax. Here the thing is that we have developed our own algorithm. So with the help of MATLAB program only, we have tried free programming. We have gone with Python. Again, we have gone with MATLAB programming and then R also. Here I'm explaining only about the MATLAB programming, how we have done that. So now this SSIM is nothing but self-structured interaction matrix. It will be helpful to find out the contextual relationship among the identified barriers. So what is the contextual relationship between each barrier? Like individual response from 12 experts were collected for pair-based comparison. So we are given a data sheet to the experts. We have asked them to use the relationship with the help of the symbol, like VAXO. We have not given any ranking or any numbers. We are given to them because this is just to avoid the biasness. Why? Because any research when we are doing it, it should be unbiased. Imagine if I am watching thriller movies in Amazon Prime or Netflix, immediately what Amazon thinks is I like only thriller movies. Again, it depends on my mood. Sometimes I may watch, sometimes I may watch comic. Even sometimes my son is watching some kids movies. So these things has to be analyzed in order to avoid that biasness. So what we have done is we are given the what do you call in order to avoid that biasness of it, we are given the symbols to make them for the ranking. So what they did is, suppose we are given the description. Suppose if the barrier I will influence barrier J, the decision maker has to give the symbol V, similarly A and then XO. Here you can see that one, this is the cumulative symbol of it. So this is the cumulative SSIM matrix. Here it shows these are the inputs which has been given from the different identified, different people. From there, we have taken highest frequency. We have taken mode. A mode is nothing but highest frequency. We all know that one. We would have gone with average, but what we thought is mode is giving a high number of resilience in this kind of system. So we had gone with the frequency, whichever, suppose if barrier number 1 to 2, if most people are given B, so we had gone with B. Here we had, you must know that one, we have targeted only the upper triangle. Why? Because it is going to be a replica of it. If 1 is related to 2, obviously the 2 is related to 1. So that is the reason we have not put any data here. So after obtaining this, now, because the computer cannot understand that BA, XO and all, that is a problem. So this program can be understood only by binary systems. Because the program what we wrote, that can identify only binary system. So what we thought is, let us go for the binary numerical value. So we have converted these values, the collected data, into a binary systems. For that, we made an algorithm. It is called the conversion rule. Suppose if ij entry in reachability matrix, suppose if the symbol is B, then ij entry in reachability matrix become 1 and ji becomes 0. This is the conversion rule. Similarly, for A, ij entry becomes 0 and then ji becomes 0. If it is O, ij entry reachability matrix becomes 0 and then both ji becomes 0. We have applied this conversion rule with the help of MATLAB programming. Why? Because operating this kind of systems manually, it's highly complicated. So we have gone with the MATLAB programming. Finally, this is the binary value what we have received. From the numerical value, it has been received from binary value. Here you can see that one from 1 to 9, 0, but 9 to 1, it is a link. Why? Because we have gone with this conversion rule. So this is the initial reachability matrix. After obtaining this initial reachability matrix, majority of the old algorithm, what they do is they will wind up with this. From there, they will be develop a model. But we have gone with the additional step to find out the transitivity. Here it shows the transitivity, the star number 1 star. The 1 star shows the transitivity. I will like the transitivity is nothing but again this transitivity analysis is performed by MATLAB programming. The transitivity is nothing but, for instance, if you consider barrier number 1 to 12, if we consider barrier 1 and 2 is having link, so that is if it is 1, there is a linkage. If that is 0, there is no linkage, like it is yes or no. Barrier number 1 to 12 is having link, 12 is having a link. Similarly, barrier number 4 is not having link with 12, but barrier number 1 is having linkage with 4, which is nothing but if A is related to B, similarly if B is related to, if C is related to A, which means both A and B is completely related. So we have to perform these operations. For that, we have gone with a MATLAB programming because this system has to search 14 into 14 matrix. Imagine like 256 times n number of iterations it has to go. So it took around like 1 day for us to run the program and find out the answer. So that is what I am telling. This is the complication in big data. The big data, what it will do is, now we made an algorithm. That algorithm has to go for n number of iterations. It will be keep on moving. It will be first it will search for the first cell. Again, it will be going everywhere. Again, second cell everywhere. First, it has to go with 14 into 14 matrix. Once it is done, again it has to check the consistency. Again, keep on. It is called like a feedback loop. It has to go with that. Finally, once all the systems are made it ready, it will stop the checking. That is what I am telling. This is what the big data means. We have a data, but when it is based on our requirement, if it is running, it is keep on going for a long time. So this is the final reachability matrix what we obtained. Here one shows the transitivity. Here you can see that one in previous slide 4 and 5 there is no linkage, but after transitivity analysis it shows that there is a transitivity linkage. After finding out the transitivity, now we have to do the level partitioning. The level partitioning is nothing but from the final reachability matrix, the reachability set and antecedent set. The rows are called as the reachability sets, the columns are called as the antecedent sets. So we have to add all these rows and then all these columns. Similar like this. This is the first iteration. Like barrier number 1, the reachability set, which is nothing but the barrier number 1 is having link between 1, 2, 3, 4, 5, 6, 7, except 9
it is having link with everything. So we are not mentioned 9 remaining thing. Similarly, for antecedent set 2, 3, 7, 8, these are not having linkage, remaining things are having link. So we have to omit 2, 3, 9, 7, remaining things are. Then the intersection check. Intersection is nothing but common between these two. Common between these two is intersection check. It's nothing but like, 1 is common, 4 is common, 5, 6. So those things has to be captured. Again, performing these operations manually, it's going to be complicated one. So this is where the big data matters. This system looks like, we have collected data from only 12 people, but those collected 12 people's data, it will take tremendous effort to analyze. That is what I said. So when it comes for the static environment or dynamic environment, collecting data, it's okay, fine, because data is readily available for us. It is like garbage in, garbage out. You put any data, the data output will come. But what is our requirement? Based on that, how we are going to develop the algorithm. When I explained in big data, that is what I said, people should have 2 skills. The one is like, you should have a systematic computer knowledge or language. The next one is you should be having the mathematics skill to develop an algorithm. This is where the algorithm comes. So again, it has to go for the n number of iterations. When they both reachability checks and intersection check both is going to be same, it will mark as a level 1. So these has to go for again and again the iterations. Similarly, you can see that one barrier number 2, 7, 8, and then 14. This has been framed as a level 1. Then those barriers has to be removed from the system. Then it has to go for the next iteration. Similarly, this iteration has to keep on going. Finally, it will end up with all the barriers. So even in our research, it has gone for 4 iterations, and then 4 iterations, all the barriers have been framed. See here you can see that one. This is our ISM model. It's nothing but from the alphabet values. From there we have made it as a numerical value. All those numerical value has been converted into a research model or a research framework. This is where it shows. This model we used to call it as a conceptualization model. Here, how we frame that model is, for example, legal and regulatory standards and the lack of internet coverage. This is barrier number 5 and 9. So these barriers has been put in barrier number, these energy management difficulty, these are in the first question, second, third, fourth. This is where it shows. Barrier number 2, 7, 8, and then 14. These in the first level, second level, third level, and then fourth level. Based on the levels, we have made it. This linkage shows that each barrier can influence any other barriers in their own level or different levels. For example, this barrier can influence all these, and also these can influence all other entire systems. So our objective, the first objective is to find out the model. So finally we came up with the model with the help of that. Again, with this I cannot give a decision maker clear-cut idea. So what we made is we have gone with the next model. So for that we have applied the fuzzy micmac analysis. The micmac is nothing but the matrix, multiplication of matrix. So in generally what people used to do is they used to go with the traditional micmac analysis. But again, for our research purpose, we have applied fuzzy logic into it. Why? Because see, our major focus is we have to make sure that this technology is having importance in Indian healthcare system. So if I want to prove that my decision should be correct, my decision should be properly captured. So in order to capture that, what we made is we had made an additional step to go for infuse fuzzy system. We all know that one in general system it is going to be only binary values like 0 or 1. It's kind of like yes or no, or whether it is having relation or no relation. But we had gone with the fuzzy scale of like this scale has been developed by us because the static fuzzy scale is different. We have made our own fuzzy scale like numerical value from if it is no relation 0, if it is full relation 0. What if it is having a very weak relation or weak relation, medium relation, strong and very strong relation? So this is the scale which we have made it, and then this scale has been infused into the same binary direct reachability matrix. The binary direct reachability matrix is nothing but Initially, what the data we have collected, the diagonal entries have been converted into 0. It's nothing but there is no relation between 1 to 1, 2 to 2, 3 to 3. Similarly, those data have been captured and then converted as binary matrix. From this binary direct reachability matrix, we have developed a fuzzy reachability matrix by infusing all those details. Again, the same fuzzy scale has been given to all the experts to rank it or to give the input about it. Again, we have collected the data from the same people with the help of fuzzy scale, 0 to 1 fuzzy scale. After obtaining that, we have gone with same frequency mode. Then finally, we have obtained these data. This is the fuzzy scale data. Previously, it was like only 0 and 1. Now it shows only 0, 0.1, 0.7, 0.1. Even though there is a relationship between 1 to 7, the relationship is very weak. That is what it shows. That. So after doing that one, we have to go with the matrix. We have to find out the stabilized matrix. Because this matrix is not stabilized at all. Whenever you are going with the decision making the data analytics, make sure that all the data which we capture, which we segregated, which we are going to analyze, it has to be stabilized. Because without stabilization, if you are performing any operation, the result is going to be a disaster. So just keep that in your mind. So in order to make that stabilized, we have approached the max-min approach. It's nothing but each cell has to be checked matrix multiplication. For example, if C is equal to A multiplication B, then the algorithm is C11 is equal to maximum, minimum of A11, B11, and minimum of A12, B12. It's nothing but row into column. Minimum of A11 and then B11, and minimum of minimum of A12 and then B21. Like row, column, it has to do operations. Here the complex system is, again, this program also with the help of matrix multiplication we have done. This hydration has to go fine. It has to stop this when both driving power and dependence power become stabilized. This is what we call a stabilized matrix. For example, if you add it here, it is not stabilized. These addition of entire row value, addition of entire column values are not stabilized. But after performing these operations, these values are stabilized. In order to obtain the stabilized matrix, it took 3 days for us to analyze. Even in MATLAB programming, we have run that program because it has to go and check each cell. Each cell it has to go. Starting from here, it has to sell each cell 1, 2, 2. For example, number 2 with all other cells. Then it has to check whether it's stabilized. If not, again it has to go with 2 with all other cells. It has to check. Similarly with 3, similarly with 4. Imagine how complex it is. That is what I mean to say that data analytics is not just like that, capturing data and then analyzing it. You must know that one, what is your output. Based on that, you have to write your own algorithm. So we made an algorithm in MATLAB and then we have put all these codes to, we have used different tools again. We have tried with R, we have tried with Python. That difference also we have shown that one. Finally, we have ended up showing that, I'm explaining only about MATLAB programming here. It shows that one, it has gone with n number of iterations. Finally, it stopped when both these things have become normal. Stabilized. From there, we have made a cluster diagram. This is a cluster diagram. Why this? See, whenever we are doing data analytics, we have to go with the clear-cut picture. Why? Because it is completely about decision making. We have to keep one thing in mind that the data analytics, big data, industry 4.0, everything will be giving a clear-cut idea about decision making. How well we are going to decision. Like it is kind of like no or go or no go. That is what it is. Major important. So here it shows that what there are 4 number of quadrants like autonomous barrier, dependent, linkage, and then driver barrier. In autonomous barrier, there is no barrier placed, which means all the barriers which we have chosen is interlinked with each other. Even dependent barrier number 2, 3, 7, these barriers are highly dependent on other barriers. Barrier number 5 and 9, these barriers are driver barriers because the people have to give more concentration on these barriers. These are the linkage barriers. For each stage, there is a cluster characteristics. Even autonomous barriers, both driving and dependence power is weak. So in our case study, there is no autonomous barrier, which means the model which we generated is not having any inconsistency. Similarly, for dependent, weak driving and then strong dependence power. For linkage, both driving and dependence is strong. For driver power, for driver barrier, driving power is strong, the dependent power is weak. So with that, we have prioritized, with that, we have made into a 4th quadrant. Now, the major objective is we have to prioritize this. This is where our next objective is. How well we are going to prioritize. I know that these barriers will influence, but imagine all these two barriers are in the same position. Which barrier is influencing which one more? That I have to prioritize. That is where my objective is. So for that, for prioritization, we have approached two major techniques. The one is DMATL technique. It's nothing but decision-making trial and evaluation laboratories. We are again we have infused fuzzy system into it. Like this time we have used a different fuzzy scale, like very weak relations to very strong relations, with the help of like triangular fuzzy numbers like 0, 0, 0.25, 0.25, 0.5. Similarly, the same data has been collected from the experts. This is the algorithm which shows that what from data collection, pairwise comparison, calculate fuzzy diagonal matrix, calculate normalized fuzzy matrix, calculate the fuzzy total range matrix, de-specify the crisp values, then establishing degree of influence, and then plot cause and effect diagram. So this is the algorithm. These things have been included by us. The crisp values and the GFCS algorithm was developed by us. So this is the data collection with these linguistic numbers. With this number again the linguistic variables. We have collected the data like 0 to 5 scale. Then that has been converted into fuzzy range matrix. Suppose if it is 3, it is going to be 0.25, 0.5, 0.75. Similarly, we have got the data. From there, again we have to normalize this data. Data normalization is nothing but like this data is not normalized data. Now we have to find out the normalized data. How this normalized data is. We have approached this formula to find out that. It's nothing but low, medium, and then lower value, medium value, upper value. So this is like for example, this is lower value, then medium. In this is upper value, medium value, lower value. Similarly, for each cell, it has been found out. Finally, it ended up with the normalized fuzzy direct logistic matrix. After that, we have to calculate the total logistic matrix. The total logistic matrix is nothing but addition of all these, the entire cells, which has to be divided by each cell values. So from there, we have find out the total fuzzy logistic matrix for all the cells. From this, we have to de-specify the crisp value because these values are not crisp value. This is in a fractions value. So now these values has to be this one has to be converted into a from fuzzy total range to fuzzy crisp value with the help of this matrix. Nothing but difference between maximum and minimum for lower limit minus minimum of lower limit. So this CFCS algorithm initially has been proposed by Optovich and Zhang. Now we have made a few modifications based on our programming input. Finally, we have obtained the total crisp value of this. This is a crisp total significant matrix. Here you can see that one we have omitted few values, which is nothing but the threshold value, because in the study the threshold value is 0.047, which means the total matrix before converting this we have made the addition of all these values, and then we have taken average number, which shows that the average number is 0.047, and that algorithm shows that if any value is less than 0.047, it can be neglected because it is not having any value addition to the system. So we have neglected values less than 0.047. Finally, we have obtained the total significant matrix. From this, again, we have added row and then column. Here it shows the R is nothing but the addition of rows and the D is nothing but addition of the column for each barrier. Now we made a D plus R and D minus R values. The D plus R, the D plus R and the D minus R value should show that one. From here we have to infer. Like what is the D plus R value, D minus R value? This is the inference for us. Because analysis now we have done how well we are going to infer these systems. For that, here it shows from here for D plus, we have to place the cause and effect diagram with respect to D plus R and D minus R value. Here it shows the horizontal values of D plus R and then the vertical values of D minus R. From -1 to 1.1, you can see all the variances has been plotted. From there, what you can say that one, in general, the positive values of d minus are represent causal variable and the negative d minus are represent an effect, which means these are the causes. The highlighted ones are causes, the remaining negative ones are effects. Which shows that barrier 5, 9, 11, and then 10, these are the causes. With respect to these causes, this will affect, these are the effects. What it means that, suppose if I touch barrier number 5, the remaining barriers will be affected. That is what it shows. In study, barrier number 5, 10 are considered to be causal, regardless of when regarded as an effect of remaining other barriers. So with that, again I'm telling you, if I'm removing barrier number 1, what effect it will be coming to here, it will show. Similarly, why I'm telling it is, it should not be, a decision making should not be a time consuming process. We all must be aware of it. My intention is I have to remove all those barriers. Now, easily I can concentrate on these barriers and then I can remove. Once if I am removing all these barriers, automatically these barriers can be eradicated. That is what it means. Rather than giving more time for these barriers and then breaking one by one, we can concentrate more on this. The policy makers and decision makers can concentrate more on it. Okay. Here it shows the cause and effect diagram. And also with this, again, we came to a chaotic situation that like all these barriers are in the same question. So how to eradicate this? In order to overcome that, again, we have developed another algorithm called AHP. It's nothing but analytical hierarchy process, which has been developed by scientist Sati. So in that way, again, we have infused fuzzy system. Here we have used, based on our requirement, we have used Buckley's method to measure relative importance of the weight. We have made a fuzzy triangular number. The fuzzy triangular number is nothing but, this is the fuzzy scale of it. Majority of the people are aware of it, I guess. There's nothing but from 0 to 9 scale, it has been like equally, moderately, strongly, very strong. So this is the limitation they have given. What about the triangular membership? Because there are plenty of fuzzy numbers are available. Fuzzy trapezoidal, fuzzy triangular, normal fuzzy numbers. Here we have employed only triangular fuzzy number. A triangular fuzzy number is very precise. Why? Because it will give data. For suppose if it is 1, 3, and then 5, it will give the median values of 2, 3, 4 also. Median between 2, 3, 4, and it will be giving lower value and upper value 2, 4. So this will be giving you a very precise result. Now this is the fuzzy scale of it. Again, numeric value from linguistic and scale value. This is the algorithm what we have used it. Here it shows the consolidated data. The data again has been collected from the same experts they have ranked, and then we have collected the data from them. From there, we have to find out the geometric mean of fuzzy comparison value. In order to find out the geometric, it is nothing but low, medium, and upper value. Then we have to find out the inverse. We have to find out. I will explain you why we have gone with the inverse values in the end of the section. Then we will understand, because directly we can consider this. If we consider it will not become a normalized value. So in order to make a normalized value, we found out the inverse value. These are the formulas which we have used for that. So after analyzing this formula, we ended up with the geometric mean value. It's nothing but low, medium, and then upper value for each barriers. So these values have been converted into low, medium, and then upper values for each barriers. It's nothing but RI. We have used donate as RI. This is the total value of this number. It's nothing but 9.167. Similarly, medium 12, and then upper limit 18. But if you consider this one, this 9, 12, and 13, here it shows low, medium, and upper. But now we have to take the inverse value. I will tell you why. One, because this value is not normalized, we have to take inverse value. It's nothing but this value divided by the whole value divided by 1. So we have been got the 0.1, 0.7, 0.5. Now if you check out the inverse value, it is not with lower. The 0.1 is not lower limit at all. The upper limit is not 0.05. Again, the medium limit is not 0.057. Now what we made it, we have made it in ascending order to show that one. So now you can see that one, the lower limit is 0.005. Then these values has been changed. This is what we used to call it as a normalized value. Because any value, if you consider, it has to come with a normalized value. When you are doing any analysis, make sure that one, you have to go with the normalized value rather than doing it in a raw value. Now these values we are going to utilize. From RI, we are going to find out the weightage criteria for WI. It is nothing but multiplying each value with the ascending value. For example, for lowering 0.45 to 0.5, here you will be getting this value. Similarly, for it has to go with multiplication will go with everything. Then finally, we will go with the weightage value by low, medium, and then upper limit. This is the W value. Now we have to go with the normalized value. Normalized value is nothing but that NI is nothing but total value divided by summation of 1 to n and then this value. This is where that MI shows here. After once you find out the value, again you have to find out the sum. You have to check this. This sum is not, equal. This is not equal because it has to be all the fractions value has to be 1. So in order to find out, again you have to normalize. Again, this value has to be normalized with the multiplication of this value. Then finally, we have got the normalized value, which is nothing but the entire system values having the cumulative value is 1. When it comes for 1, you have to stop it because these values 1.1517, which means there is an inconsistency in this model. Now we made it a normalized value. No. From this, you have to rank this barrier like 0.097, then 0.01, which is having a higher rank. This ranking has to be captured. Now here it shows the rank. Each barriers are having a rank based on their. Now it shows them barrier number 9, 5, 3 based on their ranking, and then barrier 12 is having a least ranking about it. So now here we can give a clear insight to the decision makers that they have to concentrate more input for more insights to these barriers to overcome. Once if they overcome these barriers, they can successfully implement the IoT system into that one. And also with this we have not stopped again, because it is a very huge project which we have taken. Even though we can say that this system is going to be helpful, but how well it is going to be helpful, that also we have to show that one. So when the data we have collected, we have analyzed, we have given input to the people, but now we made additional step to show them what if I am going to remove the first barrier. It's nothing but lack of internet coverage and IT infrastructure. So in order to prove that, again we have gone with simulation models to show them. This is the why we have gone for the case study of it, because the healthcare industry keep on revolving. They are also planning for their technology transformation. So this case study we have we want to show that what will happen to the healthcare system when the IoT is completely implemented. For that, again we have got this research framework of the case study, from problem statement, data collection, structure of VSM is nothing but value stream mapping, then identify future value stream mapping, development of simulation model, then simulation model for the IoT system, scheduling the resources and analyzing the results. So this has been again made it. In order to go that one, we have approached the DMAC approach. So majority of the people, we all belongs to science department, science and technology. You must aware of it. It's nothing but define, measure, analyze, improve and then control. This is the DMAC approach. So we have gone with the DMAC DMAC cycle. So here, what problem we faced is when we went and then observed that real-time hospital management system, we have observed that poor traceability and visibility of equipment, and then difficulty in coordination, long waiting time between workstation, and improper utilization of resources, and then more number of errors due to the manual and the paper-based process. So these were the main key bottleneck areas we found out. Then what we thought is, okay, we have taken additional step to show them how these things can be eradicated with the help of the IoT technologies. To prove that one, we made 3 major objectives, to minimize the patient waiting time and improve utilization of the resources, and then to develop a simulation model to generate quantitative evidence, then to make assertive scheduling to the resource in healthcare supply chain. So for that, we have gone with the value stream mapping. The value stream mapping, all you know that one, it will focus on major based across all the entire process. It will be focused more on cycle time and then process time. So these are the data which we have collected. These data have been collected for month of, around 1 month we have collected all these data. From there we have taken average cycle times of each data, for registration process, pre-examination, diagnostic test, waiting for the results and the patient treatment, recovery, discharge. All these data have been taken. We had been with that hospital. It is one of the biggest hospital groups in India. Due to the other reasons, I don't want to reveal that name. They do have their operations throughout the globe. And also, like, fortunately, they are into a process of implementing this IoT. So they have approached us, and then we, as a team, went and we have collected all those data. We have done a time study. We have collected all those data with the help of sensors, because, like, now we no need to do it for manual thing. With the help of sensors, we have collected all those data. And then this is the like description for move to recovery. When they are standing in a queue, how like what is the timing it is going to take? For example, it is a waiting time, like discharge of the patients, move to recovery, patient treatment. All these times have been captured. So this map shows the current state value stream mapping. It's nothing but the existing system. The existing system. Excuse me. This is the current state value stream mapping. It shows that how well the existing system has been mapped. When I mentioned earlier, each data analytics or each data collection method, there are n number of multi-criterion decision-making system techniques are available. We used to call it as MCDM techniques. We should make sure that which system is going to be helpful based on your objective. That is what I mentioned. I mean, keep on insisting this, because my like suggestion is, we all are very good in either in one part. Like, some people will be very good in functional thing. Some people will be very good in making algorithm, but some people will be very good in making programming. But when it comes for data analytics, it is complicated. Why? Because the person who is making that, he must be well aware of all those steps. Then only he can understand the process well. Okay, that is what I'm telling. Data analytics is what we saw and what we think. It is not data analytics at all. Because in general, we are going in depth. If you go, you have to go with n number of processes. Okay. So here we have shown the, data analytics for the value stream mapping. Here it shows that each process starting from arrival, patient, and then like diagnostic test, each project. This shows the finding, supply or waiting time of it. Now here below that it shows the two timings. The one is the 520 is the lead time. Lead time is when the patient goes in, when he comes out, what is the total time it takes for that. Then the next one is the cycle time. For each cycle, what is the timing? For example, for admission process, 15 minutes. Then for a doctor, for consultation, for 30. Similarly, for each process, it will be showing. And then remaining thing is the non-value added time, which is nothing but the difference between these two. It's called as the non-value added time. Non-value added time is it is a time, like, how much time we are wasting inside one system. So that is what our objective. Our objective is to minimize that. So from there, again, we have to find out the process efficiency. The process efficiency is 67.43%. This is the process efficiency of the previous system. This is the scenario for one of the reputed hospital in India. Then imagine what is the current status of other hospitals. So in order to overcome that, what we did is we have to show the future state value stream mapping. So we have taken one technology called RFID, because we cannot implement all the technology into the system. Why? Because it is going to work as a simulation-based system. We cannot go with straight away implementation, because that implementation is going to cost a lot. So before that only we have to make all this study. Then we have to think whether to go or no go. Then we will be approaching it. That is where the typical industry works out. Typical data analytics industry works out. Okay. So now, in order to overcome the discrepancy in the existing system, we have proposed a state-of-art modern technology called Internet of Things to enhance system for better performance. In this study, we have put RFID system. This is the assumption again. We have made few assumptions for it. Like, for example, each patient wristband would incorporate the passive RFID. Each employee name tag would incorporate RFID. All hospital equipments incorporate RFID. Then bulk hospital supply drugs can be labeled with RFID. So these things have been assumed, and then those data have been collected with help of previous published journals, and then previous published journals. From there, now the process has been streamlined. The process has been streamlined because previously the process has been not streamlined. Now from here, because when it comes for RFID, you don't need to waiting in the queue for all this stuff. Directly, the data can be captured, and then lively it can be transferred, and then lively the data can be transferred. Now again we made the future state value stream mapping using RFID technology. Here you can again you see that one there is a lead time difference and then a non-value added time difference which shows here. So here the non-value added time has been completely reduced here, and also the process efficiency has been increased. The efficiency has been increased about 92.9. This is the comparative table for existing and proposed system. Even the current system, the lead time is 522. In future system, 352. It has been decreased. Non-value added activity has been completely drastically decreased, and then the efficiency has been increased from 67 to 92. The percentage of increase is 27.2. Now you can see that when these systems comes into place, it will be dramatically changing the future. And also, like we have made an arena-based simulation model to show that how this process has been modified with the help of simulation packages. Here, these are the resources and capacity, how the resources are going to utilize. For example, 12 doctors, nurses, staff, test room and recovery bed. These are the capacity which made that one to make to the to make it to the what you call assumption. We made the interval arrival time of scheduled patient is 20 minutes, which means once in a 20 minutes the the patient arrives. That is what our assumption is. But again, you may ask that one even during again I'm telling this is the probabilistic model. Suppose if a person comes in between 20 minutes, how the system works. During COVID pandemic, whatever the prediction we made, it has proven that it is error. Again, I am telling it is once in a while those systems will happen, because these systematic approaches are only 90% value added, but remaining 10% we don't know because of the natural calamity, anything can be changed or anything can be proposed. But this is we are making ourselves for the future. Okay, so whenever in this model, whenever there is any particular process needed, we have made a tagline for find supply in that one. In order to make that one, we have gone with the triangular distribution. The timing of it completely, it's in a minute, like 5 10 50 triangular distribution we have started with. These are the resources. So this is the inpatient model for the simulation model of the existing system. So when the patient arrives at hospital, then scheduling till it will be you will be moved to recovery. It is the model for the inpatient department. Similarly, we have simulated the model with RFID device. Again, this is the simulation model with RFID system. Similarly, it shows now we have gathered data of both existing and proposed systems. So it shows that what is the percent. This is the utilization. It shows the utilization of existing and proposed. Now, what is the percentage it shows? The doctor can be utilized. Utilization can be increased for 3.29%. The reason why we are telling it is, whereas in country like India, especially in medical industry, if you take it, the doctor-patient ratio is very huge. That is what one doctor, as per the WHO systematic approach, one doctor has to be minimum, has to support 1,000 people. That is what the WHO need. Whereas in country like India, one doctor is supporting around 11,000 people. Imagine how much bottleneck or how much chaotic situation it would be. So in order to avoid that, we have shown this. This is going to be increased their utilization. This is the graph which shows that one, what is the utilization of resources. And here the comparison of waiting of existing and proposed system. In existing for 10 minutes, it has been reduced for 6 minutes. Similarly, average length of stay without IoT is 695, with IoT is 535 minutes, which shows that the percentage of decrease is 23.02%. So from this case study, what we have concluded is the simulation model has given a quantitative evidence of benefits of implementing IoT device. The waiting time of workstation of proposed system is reduced, and utilization of the resource has been increased. And also the optimum level of resource obtained by using the simulation model are useful in scheduling operation. And also the IoT will provide huge benefit in the healthcare supply chain management system when it is implemented successfully. So from that, what the research summary and final conclusions are. From this research, what we find out is, it is estimated that IoT applications can reduce the cost of medical error, and also this healthcare supply chain can be make a significant role in countries' growth. And the major research shows that the decision makers now can pay close attention to the major barriers like legal and regulatory standards and lack of internet coverage. And also the existing IT infrastructure, internet facility should facilitate the new technology adoption. Similar, like there is some technology like 5G network and RAN, because with the help of 4G network, we can access only, only up to a few level, the full potential of the system can be analyzed only with the help of 5G network or radio access network RAN, because of without any interruptions. Then finally, the findings of this research will provide important guideline for the decision makers to successfully adopt IoT in healthcare supply chain management system. So the reason why I am giving this is how, when you are doing any data analytics, you have to start with your objective, then you have to go with the full-fledged data analytics method. For that, you can use any methods. Again, I'm telling it, there is no particular data analytics method. You just keep that in your mind. There is no particular data analytics. There is no particular good or bad data analytics tools. But after collecting, how well you are going to utilize those data. That is what I told, as Mr. Dan Harley said. It is like a desire of people. Like everybody wants to try it, but nobody knows how to try it. People will think somebody else is trying, then everybody else will think I am also doing it. So when after this conclusion, it is going to be eye opener or icebreaker for everyone to understand it. What is data analytics? How we are going to capture a data? Again, what I'm telling is, we are not from healthcare background, but we know how to tackle the data, and then we know what is their requirement. Based on that, we are going to analyze the data, and we are going to give a good product. That is what the main objective of a data analyst, and then new product development people. I know many of you people have been holding a doctoral degree, and then many of you people are working on the real research problems. When you are working, go with these kind of templates. Why? Because this is how the country's growth is keep on improving, and then we as a people has to talk to our students, or we have to make sure the healthiest or competitive future generation by understanding them what is the need, and then how well we are going to utilize the resources. Okay. So now any other queries can be discussed now onwards. I will give you a quick section, because it won't be good if all the people are communicating at the same time. So what I'll be doing is, with the help of them, with the help of your coordinator, if you have any quick doubts, that can be clarified. So if anybody else is having any doubts related to big data analytics and then IoT, and then how this data can be captured, that can be discussed now. And also I have shared my email ID also. If you have any kind of doubts, just try to ping me. I will try to, possibly I will try to revert back, because I will be traveling. So whenever I am getting time, I will just try to clarify it. I am requesting all the researchers and professors to share all these things with the younger generation, and then you make them, and then you provide them with the good real-time problems so that they can work on it. Rather than doing with the same work, you ask them to, take it as a challenge, and then working on the real-time projects, even for their UG and PG level projects. At least make them too skillful in any one technique, so that they will be, because in industry it is not that easy to understand all the techniques or algorithms. We are into research, so we are doing all those steps, and then we do have a very good team also to do that. Difference between HADOP and then RDBMS. Okay, fine, and see. All these like HADOP and then RDBMS, it works on the different platform, but their their intention or their purpose is just to capture and store the data. It's kind of like, that is what I mentioned. It is like a data lake or data pool you can consider. Not only for even there are a number of tools, but we are familiar with few tools. That is what, like, we feel, as I mentioned, like it is like easy to get tools. Easy to get tools. We are focusing on that. So what I'm suggesting is these tools, there are around like, as far as I know, around like 60, 70 different types of tools are available. But which is feasible, we are going in. We are majorly focusing on Hadoop because we people are highly aware of it, and then we are doing it. Yeah, even the same operations can be performed with RDBMS also. But based on your applications, you have to take it. That is what, like, I mean to say. Again, as I mentioned, like the same program can be operated with the help of R programming and also with the help of Python. Even SPSS, like, again, the code is to be a little bit difficult. In SPSS, you can go with ANN, like artificial neural network, you can go and you can plot it. But we have used MATLAB programming just to, we have used all the programming languages, but for this case study purpose, I am expressing only about these things. Because, like, again, one more thing I forgot to tell you, don't confuse, don't think of using many of the tools. Why? Because it will give you more inconsistency in the system. Go with one system and then check whether it is going to meet your objective or not. Our main purpose is, first you have to frame the real-time research problem, shape it as a problem statement, then convert it to a research objective. For particular objective, which tool you are going to use it. That is where, like, you have to put your ideology. Other than that, like, all the tools, majority of the tools are serving the same purpose, more or less. I will share the PPT with the people, and then, like, I think, like, majority of the people are from computer science background. I'm sorry, like, I am not from computer science background, but I have changed my domain. To be honest, I'm telling it. I'm a supply chain expert, but now I cannot say that one, like, there is no deviation at all. Now the future is going to be, everybody has to be learn these things. That is what I'm telling. People has to be very good in their mathematical expressions, because when it comes to machine learning, rather than mugging, it is not, you cannot mug up. Again, that's what I mean to say. Because the algorithm cannot mug up. For some point, for syntax you can mug up, or you can learn it for syntax writing and all. But how well you are going to algorithm, it is going to happen with your free flow. I mean, you have to go with your hand. You have to think. You have to think like a functional consultant, like how well I'm going to map it. Once if you map, then the remaining things will fall in place. I have shared my email ID, but again, I will be sharing with everyone. It is I have shared my email address. Just try to ping me. When you are sending, at least you mentioned, like, you have attended so and so program. Because, like, I used to get more mails. Okay, any other doubts? So, Dr. Padmapriya, shall we wind up with this, or, like, you have some other things to conclude?
Sir, excuse me.
I think Dr. Shankar, yeah, please.
So there is a doubt from Arul. Which tool best for write an integrated chip?
See, again, I have explained you. It is a broad area to explain. First, we must know that what is their objective of the work. Suppose, if are they working in a real-time data segregation method, or are they going for implementation? Once if we know that one, I'm telling you, see, there are no good or bad tools. To be honest, I'm telling you. All the tools have been developed to simplify the process. So keep that in mind. I'm telling you, we are coming to a conclusion only after using different tools. I'm keep on insisting this. There is the same problem can be solved with Excel solver also. Even the same thing can be solved with R programming also. So what I mean to say is they have to go with one or two trial with their system. At one point they will find out this is going to be give a good way, or like this is going to give. This is going to solve my objective problem. Once if they feel that one, they can go with that. For research problem, I mean to say that one, there is no particular good or bad tool or algorithms, please. Because I am telling you, see, once what happens is, suppose if I am telling it, the particular tool is going to be beneficial, we all will be thinking in a biased manner that the moment I tell that one, we all are going to work on that one. This is human tendency. This is human tendency. So my humble request is don't go for tool initially. Don't go for any tool initially. Just try to go with your objective. Just make sure that one, what is my objective? What is my research purpose? How well I am going to make algorithm? Once you started making your algorithm, then in order to solve that, you are going to go with the tool. So that you can use any tool, because in online if you search, I'm telling you, every day people are developing tools. Majority of the companies, what they're doing is the first what I mentioned is, now you have to go back to the early 90s, how they have developed the MATLAB tool. Similarly, you have to think. You have to think that one, for the particular research, I'm going to use this tool. This tool may give a, beneficial result for particular objective. What, for example, I will tell you for your question, what if my objectives have been changed from the case study? If my objectives have been changed, immediately I am going to change the complete tools. The tool and the techniques what I have used, I am not going to utilize this for the other research purposes. So make sure that one, don't confuse, don't be biased. Very simple, don't be biased, because we people think that we all will be want to make it as an easier way. Don't think in that way, please. Please, I'm telling. It is an ocean. The data analytics is an ocean. We all will be thinking particular problem and particular, don't go with that, please. Suppose if you are having your objective, you share with me your mail ID. I will suggest you. I cannot give you a good thing. I will suggest you this tool works better on this platform. I can say that. Even like when I started also, I have got one query about like SPSS versus R. Again, I'm telling you, in some part of time you can use SPSS. Even some program you can, because R than SPSS, R will be, even I used to have R programming only when I'm plotting graphs. Because I feel that is R is giving a precise result than SPSS. Few things we will be going with the MATLAB programming, and like I am not very good in JavaScript, but many of my developers, they are very good in JavaScript. Whenever there is a need, I go and consult with them with the same data. They will be giving some results. We will be comparing that result. Then finally, when delivering, we will be saying, okay, this result is giving good input. So that is how, as a research, as a professor, as a people, that is how we have to think. That is what I told, like it is going to be value addition, not like a project like I have started with A, I am going to end up with B. No, don't do with that mentality. Think whatever we are doing, it has to give a value addition. Finally, you can conclude in your own research and say that one, we have tried different algorithm, but this algorithm fits best to the particular model. So anything else? Work with MATLAB I mentioned. Excellent to know that one. There are many number of tools. Which hardware conveys most benefit for other jobs? Okay. We are getting into deep conversation again. I'll do one thing. I will try to answer all your queries through my mail. Okay. Just ping me in mail. I will give you a detailed explanation about it. Again, one more. Sorry to interrupt, Dr. Padma. I'm telling it is an eye opener for all the people, like researchers like us, everyone. As I mentioned, I am also learning, and you're also learning. It is a knowledge sharing session.
I'm not saying we are not going to conclude anything from here. It is all about how well those knowledge what I have acquired and then how I'm going to deliver to the people, and then how well you are going to deliver the same knowledge or like in addition to other knowledges to your students as well as your knowledge and circle. That is what it's all about. I hope it will be very useful for all other people, at least to understand what is big data, how we are going to work on it. The remaining queries in your research areas and research problem, I can share it. Okay.
Thank you, sir, for your valuable information. Let me conclude the session with vote of thanks. Thank you, Dr. Dipesha. I would like to drop a quote over here. Let us be grateful to the people who feed the thirst for knowledge. They are the charming gardeners who make our souls blossom. It's one of the person like you, sir. Really, it was an excellent session, and we got an overview about the Industry 4.0 and Big Data Analytics, challenges and opportunities. I express my sincere gratitude to you, sir, for your time and effort for providing this knowledge transfer to all of us. Once again, thank you very much. I escalate my sincere gratitude to our management, secretary, principal, director, HOD, coordinators, and faculty members for having this topic part of this 6-day faculty development program. I thank all the participants for your active participation. Wishing you a good day to all of you. Thank you.
Thank you, Dr. Padma. Thank you all the participants for your immense time and then effort. I wish you all the best. Wish you all success. Let's make the country pride with our knowledge sharing session. Okay. Thank you.
Thank you, sir. Thank you.
Thank you. Thank you. Bye.
Recording stopped.